record. Sorry about that. And I have to do that again. Okay, so if you have an expression of a number written in this format, for example, 10 to the power x is equal to 250, for example. So let's label the components. So this 10 is called the base. The x is called the power or index. And this is, well, just an answer. Okay, so I think, sorry, give me a second. Greg, is there a special name for this 250?
Would be a resultant.
Result.
I'm not sure.
Okay.
Resultant?
I just put result or answer. But I don't think there's a special name for that bit here. But
No.
but if you have a for example, you've got 5 square, then that is base and that's power or index. And that's why this particular format is called the base index form. Now, again, I spend a lot of time explaining the origins of logarithm and what it means, but I sadly don't have enough time today to do that. So I will just tell you the logarithmic form. So if I write down, for example, b base x equals a, all right? This is the base index form. The logarithm, if you want to convert this to a logarithmic form, the short form for logarithm is log, L-O-G. And we write the base just below the line we write that in, that's b there. So I won't use the line, but I'll write b here. Log base b, and we take the answer and put it beside it, and the power or the index comes there. So let's see if we can do a couple of exercises just to go and switch between them. So if I write on, for example, 5 to the power 3 equals y, that's base index form. Can you write this in logarithmic form? Let's change the color of this. So logarithmic form would be log base, so base is 5, so 5. Answer is y equals the power is 3. There you go. That's the logarithmic form, that's the base index form. Let's do some more. So if you have something like x to the power 7 equals 108. That's the base, 7 is the power, and 108 is the result. So if you want to find or write down the logarithmic form of this, you run on log base x 108 equals power, which is equal to 7. Now let's go in the opposite direction. If I was writing log base 10 of x equals, let's say, 3. Write this in base index form. So base would be 10. Power would be 3 and is equals to x. Wow. Okay. That's so useful. Okay. Sorry. Yeah, that's maths at high level. Sorry, that's my 5-year-old. That's just too sad. Okay. That was too easy. Okay. Right. Okay. Right. Okay. All right. Sorry. Sorry. I just. Let's move on. I'll just use a different color. Right. So let's say log of base x let's say 150 is equal to, let's say y. Yeah, there's two variables here. Let's put this in base index form. So base is x, so x. Y is the power, so you put y equals 150. Would you be able to solve this? Don't think about it. Too hard. It's just usually when you get an equation, you will be given only one variable and not two. This is just transforming one way of writing a number to another way of writing a number. Okay, so let's do a couple more just to get the hang of it. So you've got base to the power equals an answer. All right, log to the base of an answer equals power. I think this is given in your formula sheet in year 12. I think. I may be wrong, but I think. So you don't have to cram that, but you have to be able to go from one to the other if you want to solve equations. So for example, where is it used? Well, for now, sorry, that shouldn't be the question. Let's go and look at some places where you can have some problems and you can use some simple maths and answer them. So for example, if I go evaluate, means to find a value for or calculate. 5 squared equals x. Can you do that? Yes, we can do that. X is equal to 25. Yay, done easy. So very straightforward. Yeah, let's move on. Let's find x to the power 3 is equal to 125. Right? Can we solve this without using any logs or anything like that? Yeah, we can. Right? So before we come to that, let's do a x square equals 121. So opposite of a square is a square root. So x would be equal to square root of 121. It's a plus or minus because you can have plus or minus. And you end up with x equals 11. 11 is 120. Yeah. So similarly, a cubic would be cubed root. So x cubed root of x is equal to cubed root of 125. And therefore x is equal to 5, 25, 100. I think so, 5. Yeah. I think that's 5. Right. So you must be wondering, what is this logarithm for anyway? We can solve all these type of questions, right? If you have a look here, the answer is what's asked for. So you can actually find the answer, no problem. You can have a look here. The base is what's asked for. So you can find the base by just, using a root. Here, the same thing. Base is asked for, so you can. So I think we can find the base. We can find the answer. So let's see if I can have a question where you have, let's say 8 to the power x is equal to 750. Ooh. Can we solve this using our whatever bag of tricks we have in maths? The answer at the moment is no. And this is where logarithm comes in. So would we be able to solve it straight with logarithms? Actually, no, but let's see what will happen if we write it in terms of the log. So it'll be log base 8, answer 750 equals x. No, that doesn't help us. Does it help us? No, it doesn't help us. So from here, what we do is we go into something called the 3 laws of logarithm, which I want to show you, but I should have showed it to you before I started doing problems. Sorry. I will go back and go laws of logs, right? So there's 3 laws of logarithm. I can show you how they derive, but I'm just going to give them to you. Number 1, log of, this is the same base, so we're not going to write any base, but log of any number or any variable x times y. If there's 2 things multiplied, for example, log of 2x is equal to log of x plus log of y. First rule. Second rule, log, which is the same base. So whatever, that could be base 10, that could be 10, and it could be 10, with 2, 2, 2, whichever you want. In the calculator, the log base there is 10, and then there's one which is natural log, ln. So we'll talk about that. That's discussion for another time. Division log of x minus. So the numerator part comes first, and the denominator comes second, and there's a minus in the middle. We're not going to use any of these at the moment, but we definitely are going to use this. Usually we use these for simplification exercises. The third one is the important one, because if you have log of anything which is raised to a power, then that power comes in front. And that is highly useful for us to be able to solve questions like the one which we had said. So when you have something raised to a power, the power comes in front. And so how are we going to use that and solve this? What we do here is we raise both sides to a log. Okay, so let's say log base 10, because that's what the calculator has, so make our life easier. Usually we'll use natural log, but we're not there yet. So we'll go log base 10. I'm not going to write the base, but let's say it's 10. 8 to the power x equals log of 750. All right, now we can take that n and bring it in front. So we can take the x and put in front. So x log of 8 equals log of 750. All right. Now we're talking. So log of a number is simply a number. So if you have a calculator, if you type it in, it's what I'm talking about is the on button. If you come down straight away is x factorial, x exclamation mark, and then below that is ln, and on the left hand side is log. So that log is log base 10. So x would simply be equal to log of 750 here divided by log of 8. So if I did that in the calculator, so I'll go log, sorry, switch it on first, log of 750 equals divided by log of 8 equals 3.18. I get 3.18. I can check my answer. I should have 8 to the power 3.18 giving me close to 750, because this number is long and I just rounded it up. Let's see what happens. So I go 8 to the power 3.18 and I press equals, I get 744.4. So maybe 3.8 is not, maybe I should give some more decimal points because it's out by 6. So log 750 divided by log 8 is, oh, wait, sorry, I got a different answer. Oh, no. Log 750 equals divided by log 8 equals, 3.1836. 36. Now if I do that, 3.1836, I hope to get a better answer. 8 to the power 3.1836. Yep, 750.02. So yeah, that's pretty good. So I will stop there for now, and I will stop share, and I will stop recording.